6, part 1, with this final substitution problem. Where do we start? We want one equation to be what? Okay, y equals or x equals. What's the best scenario for getting y equals or x equals in this case? The bottom one, okay? So the bottom one, it's already 2y equals. How do we make it y equals?
Divide by 2.
Divide everybody by 2. Okay, so now, if I divide everybody by 2, this equation becomes y equals 6x divided by 2 is 3x, minus 2 divided by 2 is 1. Okay, so now we have a y equals equation. And we're going to go into the other equation now. Every place we see a y, we're going to replace it with 3x minus 1. Every place we see a y becomes 3x minus 1. So now I'm going to take the top equation, negative 6x plus 2y. What's my y? The 3x minus 1. And then equals 8. So negative 6x, 2 times y, which was 3x minus 1, equals 8. Okay, this part's still similar to yesterday, right? We see parentheses, so we're going to distribute negative 6x plus 6x. 2 times minus 1 is minus 2 equals 8. What's been our next step here?
Combine like.
Okay, combine like terms. What happens here? Negative 6x plus 6x? Yeah, they cancel out. They become 0. So we are at the point where, I'm going to write this out unnecessarily, but 0 minus 2. Or in other words, what is 0 minus 2? Negative 2 equals 8, yes? Now, I don't know that I should use the word weird about this, but that was my description earlier. This problem works out a little weird, right? What's weird about this problem?
There's no like x equals.
Yeah, my variable just canceled out, didn't it? Okay. Now, what do you remember when the variable cancels out? You remember anything? We've got 2 answer choice options. In this case, does negative 2 equal 8? It does not. Okay, that's key to notice. We have my variable's dropped out. I have a false statement remaining. So since negative 2 does not equal 8, okay, solution. Last question. There's what? Got a guess?
No solution.
No solution. Okay. So this one is a no solution.
So I have a question for you. I've noticed a couple of students as I was walking around that they are solving the y equals 3x minus 1, and then they're plugging that back into the same equation instead of using the other equation, the negative 6x.
Yeah, you don't want to. Okay, so are you saying you saw students take y equals 3x minus 1 and plug it into 2y equals 6x minus 2?
No, the y equals 3x minus 1, which I'm
So they end up with 3x minus 1 equals 3x minus 1?
kind of. So
Okay,
they just need
so-
to know that they have to solve for one,
Right.
but use the other.
Right. And I will say, I think in every single other problem, it just so happened the top equation was the x equals or y equals, right? And I'm guessing that's if you got stuck on that. In every equation, the top equation was x equals or y equals. In this case, we made the bottom equation x equals or y equals. So just be aware, you have to use the other equation. If you try and take what you just solved and somehow put it into the other equation, that's not going to work. Okay, we've got to go back into the other equation. Okay, so yeah, kind of be aware of that. Okay, so this one, because my variables canceled out and it was a false statement, was no solution. Do you guys remember what it would be if this had become a true statement? What if we'd ended up with 8 equals 8? Or negative 2 equals negative 2? The variables are still gone, but it's not no solution because it's a false statement. There are how many solutions? Infinitely many solutions. Okay? Okay, so this no solution means my lines are parallel. They never cross, they never touch. Okay? My infinitely many solutions means the lines are the same. They land on top of each other, so they're going to touch in infinitely many places. Okay? Okay. Got a little bit of a grasp on substitution? Because now we've got the other one to do. Okay, you've got your examples in front of you, right? But now we've got to talk about elimination. With substitution, we want x equals or y equals. With elimination, what I like to see is when I see one of my variables, either x's or y's, have the same coefficients. So we can eliminate a variable. So I'm not going to do any solving right off the bat. But what do you notice here? If you look at both of my variables, the x's, what about those x's? They both have a 4 in front of them, right? Now, on this particular problem, one of them's a positive 4 and one's a negative 4. Okay? How do you get a positive 4 and a negative 4 to, I'll use the word eliminate, cancel out?
Add them.
You're going to add them. So this is where we're going to set it up that we're going to add our two equations together. So I'm going to draw a line here. I'm going to put a plus sign out here. Now, in this particular problem, notice everything's already lined up, yes? X's with X's, Y's with Y's, equal signs with equal signs, numbers with numbers. Okay, that's the format I like to use. So let's add. 4x plus negative 4x is 0. It's gone. I don't need to write anything. 2y plus 3y is 5y. Carry down your equal sign. 9 plus 16 is 25. Now, we just took two equations, eliminated the x's, combined them to one equation. How do we solve 5y equals 25? We're going to divide, right? So we're going to divide both sides by 5. And what do we know? Y is 5. Am I done? On the entire front page where you grabbed, where you substituted, my answers have always been ordered pairs, yes? Just like everything else we've done in this lesson, I need an x and a y every time. Unless it's a weird no solution or, something like that. But what do you think we're going to do to find x?
Plug in.
Yeah, we know y. So take what you know. In this case, we know y. Plug it in. Which equation do you want to plug it into? Okay, Zeke picks the top one. Does everyone have to pick the top one? No. Most of you are going to pick the top one because it's one without a negative, right? I know how you guys roll. So, okay, so pick one of the equations. I'm all good with the top one. So 4x plus 2y equals 9. And we're going to take y equals 5 and plug it in. So 4x plus 2 times 5 equals 9. You've got some math to do, right? 2 times 5 is 10. If it's 4x plus 10 equals 9, what do we need to do to solve? If it's 4x plus 10, I want to subtract 10 4x carries down. 10 minus 10 is gone. Equals 9 minus 10? Negative 1. If it's 4x equals negative 1, what do I do to solve? Divide. We're going to divide by 4. Huh?
Did the office call you?
They did not.
Okay, she said that she can give me a slip. She told me to just go and that she would fix it on Skylar.
Okay, sounds good. Because I have you marked absent, so I'm going to trust that they'll fix it then. Okay, divide by 4. Some of you may not like this answer, but we're right, guys. Okay, 4x divided by 4 is x. Negative 1 divided by 4? I personally would leave it as negative 1/4. Okay, it is the decimal, negative 0.25. Okay. But I would leave it as negative 1/4. Now, Savas, see what they say. Okay, I would guess they'd want fraction. They'd say integer or fraction, but you never know. They might accept either or. Now, how should I express my answer, do you think? XY, so negative 1/4 comma 5. Okay. Okay. Does elimination seem familiar at all? A little, maybe, maybe not. I'm getting mixed results. Some people are like, yeah, kinda. Some people are like, nah, no. So, okay. Well, there's your process. Now, obviously, each problem's going to be a little different, isn't it? Okay. So, this setup was our beginning of the, beginning setup. X's had the same variables, or the same, coefficients. They just had, and the arrow had opposite signs even. Okay, so we are good to go there. Okay. Next example. Negative 2x plus 8y equals negative 8. Negative 5x plus 8y equals negative 20. My question to you. What variables would you like to eliminate? X's or y's? Okay. Y's in this case? Because this case, both of my y's have coefficients of 8. Now, what's different about this problem? I mean, we're doing y's instead of x's, but also what's different is if we add these equations as is, 8y plus 8y does not cancel. Now, we have two different options of how we do this. And I've taught it both ways over the years. And I don't remember what Mrs. Rogers teaches. You guys, for 8th grade, would have had Weaver? I have no idea what he taught. So, we can do this one of two ways. If they're both positive 8y's, one option is to subtract the two equations. Okay? And I'll be honest, that's not usually what I teach anymore. Now, I'm okay if you guys want to subtract. If you subtract, you just have to remember, it's not just 8y minus 8y you're subtracting. You're subtracting everything in the bottom row, yes? So negative 2 minus negative 5, and negative 8 minus negative 20. The other option, and this is the option that I go with at this point, again, I'm okay with both, they're both good, is if they're currently the same sign, how do we make one of them become an opposite sign? Multiply by a negative. Okay? So I'm going, and it doesn't matter which, I'm going to suggest we try multiplying the bottom by a negative 1. Okay? Now, if you're saying, I don't like where you're going with this, I would rather try subtracting. Then try subtracting and meet up with me here in a moment, okay? What did Mr. Weaver teach?
I think he talked about,
Okay.
like, showed us what was new.
Okay. What did Mrs. Rogers teach? Don't remember? Okay, fair enough. As I said, I'd try and go with what, but you guys didn't all have the same teacher in the past, so. Okay, so what we're going to do. First of all, my top equation, I'm just going to rewrite it over here. negative 2x plus 8y equals negative 8. I'm not changing that top one. My bottom equation, when I multiply it all by a negative, negative 5x becomes positive 5x. Plus 8y becomes minus 8y. And negative 20 becomes positive 20. Now, what do you notice about the 8y's? I have a positive and negative, yes? So I opt to teach this as I'm always trying to get opposite signs, so I can always add. So now I can put a plus 8y and a minus 8y together. Okay? So let's add. Negative 2x plus 5x is what?
3x.
3x. 8y plus minus 8y. 0, they cancel. Carry down your equal signs. Negative 8 plus 20 is 12. Okay? Now we have the equation 3x equals 12. So, you guys know the drill here. Divide by 3. And x equals what? 4. Am I done? Nope. We need 2, right? What do you want to do with the x equals 4? Plug it back in somewhere, yes? I don't know, which one you feeling? They both have negatives, so if you're, I would go for the original one of the original equations. It doesn't matter which. They both have negatives. What? The top has smaller numbers? Is that where you guys go? So, okay, if we do that, I'm going to bring this down here. Negative 2x plus 8y equals negative 8. And I'm going to plug in x equals 4. So, negative 2 times 4 plus 8y equals negative 8. Negative 2 times 4 is negative 8 plus 8y equals negative 8. My golly, that's a lot of 8s. Okay, keep our heads on straight though. How do we solve for 8y? Yeah. How do we move this negative 8? We want to add this 8 over, don't we? So to get 8y by itself, move the negative 8. So we're going to add 8 over to the other side. Now, negative 8 plus 8 is 0. Cancels like I want it to. Carry down your 8y. Negative 8 plus 8 is 0. Keep going. A 0 does not mean the world is over. Okay, it doesn't mean this problem is done. How do I solve for y? We're going to what? Divide by 8. Okay, my variables are still there. We're going to keep going. 8y divided by 8 is y. What's 0 divided by anything? 0. So y equals 0. When the variables cancel out is when we're done. But numberings cancel out is just a 0. We still had a variable to work with. Okay? Final answer of 4, 0. Okay. Got the basic feel for elimination? Because if you look at the next one, you know we got to change it up more, right? Okay, so we can eliminate x's, we can eliminate y's. If they're opposite signs, just add. If they're the same signs, I suggest you multiply one by a negative and then add. Okay, let's try the next set. 2x plus 7y equals 4, and 3x plus 5y equals negative 5. Well, What just changed up on us? Can I eliminate it?
Same number.
Yeah, we don't have the same number. Can I eliminate x's as is? No. Can I eliminate y's as is? No. We've got to have a different plan. We need to make either our x's the same or our y's the same. It doesn't matter which. We can either make the x's become the same number or the y's become the same number. Thoughts on how to do that? What do you remember?
Multiply the top by 3 and the bottom by 2.
Mm-hmm. Okay, so multiplying the top by 3 and the bottom by 2 means we're going to end up with 6x in both cases, right? Now, in that case, if we just do 3 and 2, we end up with both of them being positive 6x, yes? And if you're someone comfortable with subtracting, could you then just subtract? Yes, but what am I going to teach? I'm going to teach, let's make one of those a negative, okay? I'm good with either way, but that's how I opt to teach it. Are we understanding here? So the top equation multiplies by 3. The bottom equation multiplies by 2. And make one of those a negative, either -3 or -2. It doesn't matter which. I don't know why, but I tend to do the bottom. It's just me. Okay, and let's rewrite them. If we just multiply the top by 3, everything multiplies by 3, yes? 6x plus 21y equals 12. Every term multiplies by 3. On the bottom, everything multiplies by -2. So now I have -6x minus 10y equals +10. And this is where I say, okay, I have a +6x and a -6x. How do I get those two to cancel each other out? I'm going to add my equations together. 6x plus -6x. Cancel, gone. 21y plus -10y. 11y. 12 plus 10.
22.
22. Well, that's a good sign. I like it when I can see good things happening here. 11y equals 22 means what? Divide by 11, and y is 2. Okay? Am I done? No. What are we going to do with y equals 2? Go plug it in somewhere. Now, my recommendation, one of your two originals. Okay? Yes, you could do it with one of these, but you've got bigger numbers over here. I always suggest we go for one of the originals. So, doesn't matter which. No. You guys have a preference? Huh? Top one? Okay. So if I go here and grab my top one, 2x plus 7y equals 4. And bring in the y equals 2 if you haven't. 2x plus 7 times 2 equals 4. 7 times 2 is 14. So 2x plus 14 equals 4. And then you're going to, it's 2x plus 14, subtract 14. 2x equals 4 minus 14 is -10. And divide by 2. x equals what? Negative 10 divided by 2 is?
-5.
Negative 5. Okay. If you're struggling with why I'm doing something, please ask. Okay? Ask me now, ask me later. On the basic equation solving, I'm just trying to keep us moving. Okay? I feel like we probably know the basics here. So, don't you love my door? Yeah. Okay. I really should have zoomed in on this screen differently, but that's all right. Okay, let's try that same process again. As we look at the fourth elimination example, well, my x's aren't the same. My y's aren't the same, so I'm not set up to eliminate anything, of course. What would you like to eliminate here?
The x's.
Okay. If we eliminate the x's, what are they going to become?
15 and negative.
Okay, we'll make them 15 x's of some sort. What's the other option here? If we want to eliminate y's, what would they become? 14 y's? Because you could do 7 and 2, 2 and 7. Okay? Now, really in the same ballpark, aren't they? Okay? I think in my notes, and this is just me, because we just eliminated x here, in my notes I opt to eliminate y. Now, I think I'm probably going to eliminate y. Does that mean you have to follow me and eliminate y? It does not. Okay? If you feel confident and you're like, no, I like my x's, then eliminate x's. Okay? If I read into this problem on my own, I don't know what I do. They're both, about equivalent, so. Okay. If I eliminate y's, 7y has to multiply by 2. 2y has to multiply by 7. One of them needs to be a negative to make them opposite signs. Personally, I don't know why. I just tend to multiply the bottom by a negative. But you do you. If one of them was already a negative, we'd just leave the signs alone. Okay. Top equation for me when I multiply by 2 is 6x plus 14y equals 30. My bottom equation, when I multiply by negative 7, negative 5x minus 14y equals positive 28. My y's have opposite signs. So if they are opposite signs, in order to get them to eliminate, we're going to add. 6x plus negative 35x. So 35 minus 6 is 29x. And it's going to be a negative. 14y plus negative 14y cancels. And 30 plus 28 is 58. This is good news. This works, I promise. If you're saying, I don't know this math fact, it's good. It's negative 29x. We're going to divide by negative 29. Take a guess, folks. How many times is 29 going to 58? 2. And positive divided by negative is a negative. Not our everyday division facts that we necessarily know off the top of our heads, but yeah, it's legit. It's logical. Okay. And find the other half of your answer. Pick an equation, yes? Either or, whatever makes you happy there. think I'm gonna use the bottom. Again, really just because I can. I don't really have any other reason other than that. So 5x, 5 times negative 2, plus 2y equals negative 4. My spacing is not good. 5 times negative 2 is negative 10, plus 2y equals negative 4. How do I get 2y by itself here? How do I move the negative 10 to the other side? We're going to add 10. Negative 10 plus 10 cancels. 2y equals negative 4 plus 10 is 6. If 2y equals 6, what's y? 6 divided by 2 is 3. Okay. Final answer, xy is negative 2, 3. Okay. Did any of you try and go the opposite way of me? Did it work? Okay. Okay. One more. Which one of the backside? What do you want to eliminate? I was watching Zeke throw his hands up like, could we eliminate x's? Yeah, you already have a positive 3x and negative 3x. Could you eliminate y's if you wanted to? You already have a positive y and a negative y. Okay, let's just eliminate. If I say I'm going to eliminate x's, they're already opposite signs, yes? I have a positive 3 and a negative 3. So let's say we're eliminating x's. Okay, what is negative 3x plus 3x? 0. What is y plus negative y? 0. So what's left on the left-hand side? 0, yes? X's cancel, y's cancel, nothing's left. My variables all just canceled out. Is that kind of making you think something? On the right, this is important. What's negative 5 plus 5? 0. Okay, guys, we're done. We just have to write down our answer. All variables canceled out, which means I have two options. We talked about them earlier. It could be no solution, or it could be infinitely many solutions. What do you know about 0 equals 0? Is that a true statement? 0 does equal 0. So since that's a true statement, infinitely many solutions. Infinitely. My gosh, I can't spell this morning. Okay. Okay. You have like 5 minutes. You can do a smidge of work. Okay. So you're looking at lesson 1.6, part 1. You see a little bit of everything, right? Graphing, substitution, and elimination.